Hello, our dear students. We are going to study solving inequalities in Q, the set of rational numbers. For example, if we have x plus 3 less than 5 and the substitution set is negative 2, the set of numbers negative 2, negative 1, 0, 1, 2, and 3. Then we want to solve this inequality and represent the solution set on the number line. First, at x equal negative 2, so it will be negative 2 plus 3 is, yes, 1 is less than 5, so it's substitute the inequality. At x equal negative 1, negative 1 plus 3 is also less than 5 because 2 is less than 5, so negative 1 substitute in the inequality satisfy the inequality also. At x equals 0, we have 0 plus 3 is less than 5, so 0 satisfy the inequality. At x equal 1 is 1 plus 3 equals 4 less than 5, so 1 satisfy also the inequality. Then at x equal 2, we have 2 plus 3 equals 5 not less than 5, so at x equal to 2 doesn't satisfy this inequality. At x equals 3, we have 3 plus 3 equals 6 greater than 5, also not satisfying the inequality. To represent the solution set, we have negative 2, negative 1, 0, and 1 on the number line. We make bold dots on each of these numbers. Now the properties of inequalities. We know that 6 is greater than negative 9, and this is a true inequality. The first property, if we have 2, to add 2 to the both sides of this inequality, the inequality is still true, so 6 plus 2 is greater than negative 9 plus 2 because 8 is greater than negative 7. So we can add a constant number to both sides of the inequality without a change in the inequality relation. Another property, when subtracting another constant by subtracting negative 7 from the both sides, so we have 6 minus 7 greater than negative 9 minus 7, and the inequality is still true. Don't change the inequality relation also, because negative 1 is greater than negative 16. Number 3, when multiplying the both sides by 5, so it will be 6 times 5, also greater than negative 9 times 5, because 38 is greater than negative 45. So multiplying the both sides of the inequality by a positive number doesn't change the inequality relation. By dividing the both sides by 3, also we will have 6 divided 3 greater than negative 9 over 3, because 2 is greater than negative 3, so it's a true relation or a true inequality, because dividing the both sides by a positive number doesn't change the inequality relation. By multiplying the both sides of inequality by negative 1, What will happen when multiplying or dividing by negative constant or negative number? Yes, 6 times negative 1 greater than negative 9 times negative 1. So now we have negative 6 greater than 9. It's a false inequality. So we must change the sign of the inequality to be negative 6 less than 9, and then we have a true relation or a true inequality. So we note that if we multiply the two sides of the inequality by a negative number, then we change the sign of the inequality to the opposite sign. Also, when dividing by a negative number, we change the sign of the inequality to the opposite sign. If greater than, it will be less than, and so on. Divide two sides, yes, by negative 3. For example, we have 6 by divided negative 3 greater than negative 9 by negative 3 divided by negative 3. So negative 2 greater than 3 is a false inequality because negative 2 is less than 3. So we must change the inequality sign to be, yes, negative 2 less than 3. In general, we have these forms as the properties of the inequalities. If we have A less than B, then A plus constant C less than also B plus the same constant C. If we have A less than B, then we subtract the constant from the both sides, so we have A minus C less than also B minus C. If we have A less than B and C is a positive constant, then A times C or AC is less than BC. Number 4, if we have A less than B and C is a positive constant, so we have A over C less than B over C. Yes. But when we have C as a negative number, we change the sign of inequality. So number 5 and number 6 by multiplying by a negative constant C. So we have when A is less than B, AC is greater than, not less than, greater than BC. And number 6 also, if A less than B and C is a negative number, then A over C is greater than B over C. Remark: if A and B are two rational numbers not equal to 0, and A is greater than B, then 1 over A less than 1 over B. First example, find the solution set of the inequality x plus 2 less than 5, where the first case is x belong to z, second case x belong to n, and we know that z is a set of integers, n is a set of natural numbers, and represents the solution set of the numbers on the number line. To solve this inequality, in the first case, we have x plus 2 is less than 5 by subtracting negative 2 from both sides. So we have x plus 2 minus 2 less than 5 minus 2. So x is less than 5 minus 2 is 3. X is less than 3. In the first case, if x belongs to z, the solution set here will be 2, 1, 0, negative 1, negative 2, negative 3, and so on. So the solution set will be all the negative numbers and 0, 1, 2. As shown on the number line, we take from 2 to all the negative numbers. The second case, when x belongs to natural number, so the solution set will be 2, 1, and 0. Only make 3 dots on these numbers on the number line. Find the solution set of the inequality 2x minus 5 greater than 5, where in the first case x belongs to the rational number q, and the second case x belongs to z. Solution: 2x minus 5 is greater than 5 by adding 5 to the both sides. So we have 2x minus 5 plus 5 greater than 5 plus 5, which is equal to x greater than 10. By multiplying the both sides by half, yes, to get rid of the numerical factor of x, so it will be x greater than 10, 10 over 2, which is equal x greater than 5. Now, when x belongs to q in this inequality, so the solution set of all the rational numbers which are greater than 5, then we can write by characteristic property method, because it's difficult to list all the numbers of these sets. So the solution set here is x such that x belongs to q and x greater than 5. The second case, when x belongs to z, so the solution set is all the integers which are greater than 5. So the solution set will be 6, yes, greater than 5, 7, 8, 9, and so on.